So let's have our problem number 2 for your generator. A 4-pole 900 RPM DC machine has a terminal voltage of 220 volts and an induced voltage of 240 volts at rate speed. So the armature circuit resistance is 0.2 ohm. So is the machine operating as a generator or a motor? So compute the armature current and the armature on the number of armature coils if the air gap flux pole is 10 milliweber and the armature turns per coil are 8. The armature is wave-wound. Okay. So first things first, before we would attack the problem, let us identify the given. So we have our terminal voltage of 220, induced voltage which is our EG, which is equal to 240, or RA 0.2 ohm. Now this is a shunt connected or that is shunt connected because it's already given. We have already our induced voltage terminal, our terminal voltage, and our induced voltage in our RA. Take note that our RL is in parallel with our RSH, so therefore we may already, or we can find for RA immediately by taking our KVL. Okay, next is that, is the machine operating a generator or motor? Now, since we have our induced EMF which is equal to 240 volts and our terminal voltage is 220 volts, so therefore we may conclude that this is a generator. Okay, this is a generator. Compute the armature current and the number of armature coils. Okay, armature coils, not conductor. That is the armature coils. Okay, so if the air gap flux per pole is 10 milliweber and the armature turns per coil are 8. Okay, so let's have our first, or let's answer our first question. Okay, for letter A, compute the armature current. So for our A, let's compute for our armature current IA. So solving for IA. Now before you would solve this one, it is necessary, or if you cannot understand the problem first, it is necessary to write the diagram, which is equal to 240 volts and it has an RA equal to 0.2 ohm, which is equal to our RA, and then we have our RSH. But since the terminal is already given, which is equal to our V terminal, which is equal to 220 volts. Now, since they are connected in parallel, we may assume, or we may conclude, that this is also equal to 220 volts. Now, taking KVL at both sides, of course, we have our VA. Or taking KVL at this mesh 1, we'll have negative EG plus VA plus VT equals 0. Now VA is equal to IA multiplied by RA, so therefore we'll have a value of our VA which is also equal to our EG minus VT. Now in this case, you have our EG which is equal to 240 minus our VT which is equal to 220. Now our VA is equal to IA multiplied by our RA. So therefore we may say that our IA is equal to 240 minus 220 divided by my RA, which is equal to 0.2 ohm. So from here I will have 240 minus 220, which is equal to 20, divided by 0.2. So we'll have a current IA equal to 100 ampere. Okay, next, armature coil. Now for letter B, we use our formula EG is equal to our P zone over 60A. Wherein the generator in the problem is wave-wound. So therefore, our A is equal to 2M. And since it is not duplex or triplex, our M is equal to 1. Right? So from here, let's identify the given. We have our EG which is equal to 240 volts. Our number of pole is 4. And Z is not coil, right? Is our conductors. Okay, So 4 multiplied by z multiplied by phi which is the flux per pole which is equal to 10 milliweber per pole multiplied by n which is equal to 900 rpm divided by our 60 multiplied by 2. So in this case you may use your shape solve. So alpha calc, we have 4 multiplied by alpha x multiplied by 10 times 10 raised to negative 3. We have multiplied by 900 divided by 60 multiplied by 2. So our x or our z is equal to 800 conductor. Now, if you are attentively listening to my lecture, I have stated that there are 2 turns per conductor. Okay, so from here it is given that the armature turns per coil is equal to 8. So from that I may say that we have 2 turns per conductor. No, this must be 2 conductors per turn. Okay, so I will okay yeah, because one turn you already have 2 conductor sides. Okay, so from this we have 2 conductors per turn and we have 8 we have turns per coil is 8. So we have 8 turns per coil, so multiplied by 2 conductors per turn, so therefore we'll have 16 conductors per coil. The question is about armature coil or the coils, therefore is equal to the number of conductor which is equal to 800 conductors divided by 16 conductors per coil. So therefore cancel out the conductors, we will have 800 divided by 16. So we'll have one answer equal to 50 active coils. Okay, you may search for the book and the answer might be 500, but based on my calculation that is 50 coils. Okay, so if you would base it on the given by the problem. Okay, so in your sheet work, if you write there 8,500, so there might be wrong into your answers, okay, or into your calculation. For second, might open your phone while answering the problem. Okay,